Well, now in mechanics, the very first topic is regarding the units and measurements. All physical quantities like velocity, acceleration, length, mass, time, etc., they have some specified units and how we measure them. So there are different devices. So regarding units, we know that there are MKS, CGS, and FPS units. But in practice, we normally use MKS units or SI units and the CDI units. Now, there are some important practical units for certain quantities. Now, the quantity is supposed to be the mass, and unit we can take as solar mass. This is given as 2 into 10 to the power 30 kilograms. The order of the number is 10 to the power 30. Then comes Dalton, and 1 Dalton is equivalent to 1.66 10 to the power minus 27 kilogram. Well, 1 Dalton is also expressed as 1 atomic mass unit, and that was explained by Avogadro. Avogadro stated that atomic mass unit is supposed to be the smallest unit of mass, and 1 atomic mass unit is given by function 1 over n, where n is supposed to be the number of molecules, or n is supposed to be the number of atoms, that is, for 1 gram atom or 1 mole atoms, the number of atoms are 6.023 10 to the power 23. And similarly, for 1 kilogram atom or 1 kilomole, the number of atoms will be 6.023 10 to the power 26. Then another unit is Chandrasekhar limit. It's a very big unit of mass. It is 1.4 times of the mass of Sun. The next quantity is pressure, and pressure can be expressed in terms of Pascal, the bar, and the Torr. 1 Pascal is supposed to be 1 Newton per meter square. 1 bar is another practical unit for pressure. It is 10 to the power 5 newtons per meter square. Then comes 1 Torr. It is expressed in terms of mercury. So 1 Torr means 1 mm of mercury column, because mercury barometer is generally used for the measurement of pressure. Then we come towards area. The units of area, as it is, all of them are acquainted, that is centimeter square, meter square, millimeter square, but very small unit of area is supposed to be bar. That is, 1 bar is 10 to the power minus 28 meters square, or it can be written as 10 to the power minus 24 centimeter square. Bar is a unit for representing the surface area of nucleus. Then another unit is for radioactivity. Well, radioactivity is basically the rate of disintegration, and larger the rate of disintegration, larger will be the radioactivity. Or radioactivity is a phenomenon in which radiations are given out from an unstable nucleus. All nuclei which have atomic numbers, that is between 82 and 92, or between 92 onwards, they are supposed to be radioactive elements. The unit of radioactivity is basically becquerel. 1 becquerel is 1 disintegration per second. When we use the term 1 disintegration per second, we mean that 1 atom is breaking in 1 second, or 1 nucleus is breaking in 1 second. We can't expect more than 1 nucleus in 1 atom. Now, further is the cancer, that is the unit of cancer, that is taken as Rontgen. So Rontgen is basically the radiation dose, and the radiation dose is supplied to a particular part of the body depending upon whether the magnitude of cancer is more or less. However, 1 Rontgen is 83.2 ergs, or if you multiply this number by 10 to the power minus 7, the value comes to be in joules. Then next is about the time. So very small unit for time is supposed to be shake, that is 10 to the power minus 8 seconds. Now, there are certain important units of length, the very big units and very small units. We find that the very big unit of length is light year. It is supposed to be 9.4 1.48 into 10 to the power 15 meters. Light year means the distance covered by light in 1 year. And we find that the velocity of light is 3 into 10 to the power 8 meters per second, or 300 million meters per second. That is, in 1 second, the light can travel 300 million meters, or 3 into 10 to the power 8 meters. So light year means the distance covered by light in 1 year. Then comes parsec. Parsec is further bigger than light. It is supposed to be 3.26 light years, or it is 3.084 into 10 to the power 16 meters. After this, a very small unit of length comes, and that is Fermi. Fermi is a unit for recording the size of the nucleus. Size means the diameter, and it is found to be of the order of 10 to the power minus 15 meters. Next is 1 angstrom unit, that is the sizes of atoms or interatomic spacings are represented in terms of angstroms. That is, 1 angstrom unit is 10 to the power minus 8 meters. Next comes the micron or micrometer, that is 10 to the power minus 6 meters. Generally, the sizes of virus, bacteria, or microbes are found to be 10 to the power minus 6 meters. And next is about the nanometer, still a smaller unit, and 1 nanometer corresponds to 10 to the power minus 9 meters. Then comes pico. Pico is also a very small unit of length. 1 picometer is 10 to the power minus 12 meters. Atto is a very, very small unit, and 1 attometer is 10 to the power minus 18 meters. In order to increase the knowledge, attometer is generally the unit for recording the sizes of the radio sources in the space. So the radio sources, they are represented in terms of attometers. Radio source means any material which is sending the radio waves. And next is about the astronomical unit. It is a bigger unit. It is the distance between the center of Earth and the center of Sun. So it is found to be 1.496 into 10 to the power 11 meters. Well, we can write this number in terms of significant figures. That is, in the given number, if we remove 9, it will become 1.5, 10 to the power 11 meters.